Alright, I don't know if I need to keep drawing this cone every time, but actually it's pretty good because you get to see H, R, and L in the big right triangle thing. Alright, they tell you on this one that the lateral area is 609 pi. That's half times P times L, which here is half times the circumference of the circle. And I know the radius is 21. So when I use this, I'll be able to find L. That's 609 pi. What? Where did I start drawing that 2? 609 pi. Okay, so pi's cancel. Half of the 2 cancels itself. 609 divided by 21 is going to be L. 609 divided by 21. 29 is L. Okay, so L is 29. Height is in a Pythagorean triangle. Oh yeah, 21, 29, that makes a Pythagorean triple. What is it? 29 squared minus 21 squared. It's a nice square number. I can't remember what it was. Oh, it's 20. Alright, so H is 20. That's nice. I'm supposed to know that one. 20, 21, 29. Total area is the lateral area plus a base. Lateral area I know is 609 pi. Base I can find pretty quickly because it's, whoops, that's plus pi r squared. 21 squared is 441, I believe. I'm supposed to add that to 609. It should be a nice number. That's exactly 1050 pi. And this is 1/3 times area of the base times the height. I have all the ingredients for this. 1/3 times pi r squared times the height. Yee. Big numbers. 21 squared times 20 divided by 3, 2940. Okay, draw the next one. Okay, this is an interesting one. They tell us everything, they tell us volume first. Volume's weird because it's, oh, they do give us the radius, which is nice. Volume is 1/3 area of the base times the height. So that's 1/3. I do have radius, so that helps. Pi times radius squared times the height. So it looks like this is going to help me find the height before I find anything else. Once I have the height, I have Pythagorean triangle tells me the slant height, so I can find everything else by that time. All right, this equals 600 pi. The pi's cancel. 15 squared is, I don't know, it's 15 times 15. Let me just write another 15 here, because I didn't know 15 divided by 3 is 5. I can divide both sides by, well, what do I have here now? I have 75h. I'm going to 75h equals 600, so I'll just take 600 divided by 75. That's fast enough. 600 divided by 75 is 8. So that would be h. H was 8. All right, 15 and 8 is in a Pythagorean triangle with a 17, so that's slant height. This is half PL, which is a half times perimeter, which is 2 pi r. And L I just found out was 17. So this is half times 2. That cancels each other. 15 times 17, I can't do it in my head. But it's that. It's 255. Okay. And total area is lateral area plus a base. Lateral area is 255 pi plus pi r squared. R squared is 225. I'll just add it like this. I get 480. I'm all in pi, so I can just add them all up. All right, it's exactly like the last one, but different numbers. 1/3 the area of the base times the height. The area of the base is not too bad. It's 81 pi times the height, so it's going to help me find height. This equals 324 pi. So I can call this 9 times 9. Pi's cancel. 1/3 of 9 is 3. 3 times 9, I have 27. 324 divided by 27 is what I'm looking for. I'm sure it's a nice number because of this book. All right, this is 12. 9, 12. You should have seen this a zillion times by now. This will have to be 15 in the Pythagorean triangle. Lateral area is a half PL, which is a half times perimeter of the base, 2 pi r. times the slant height I just figured out. Half and the 2 cancel. 9 times 15. I think it's... Well, I'm not going to say. I'm just going to do that and tell you I knew it all along. Yeah, it's 135. 135 pi. Okay, and then total area is the lateral area plus 1 base, which is 135 pi plus pi r squared, which is 81. More pi's to stick on there. So there's 216. Okay, great. Just when I thought I was done thinking about that table of things, they tell you that in 17 that k equals a half. By now, maybe you've learned about this, that surface areas and volumes compare as k squared and k cubed. So if the area of a length is half, the area of the lateral areas, is part A, would have to be a half squared. It would be k squared, which is 1 to 4. In B, they want you to do total area. This doesn't really equal. The ratio of total area is the same thing, because it's also a two-dimensional measurement. So we're talking about squaring k again, so it's 1/4. And C, they want... Oh, I missed with my line here. That's kind of funny. Put a line right through the answer. Can I just... Oh, that's going to drive me nuts. Can I just grab that one thing? What? Well, this is dumb. I can do that. I'll show you Promethean software. Okay, right, I want to see now. I want the ratio of volumes. The ratio of volumes is going to be k, guess what, cubed. So that's 1/8. All right. In 19, if we're talking about a cone and a cylinder that have the same radius and the same height, it's going to look like this. It's going to look, you could stick the cone right inside the cylinder, and you know the volume of the cone is 1/3 area of the base times height. Well, base times height by itself would have been the whole cylinder. So this is just actually 1/3, because there's a 1/3 in the area of the volume formula for the cone, but not in the cylinder. Everything else is the same. All right, they want the volume of this pipe. I think I did this in class. First of all, let's think all in centimeters or all in meters so that we don't confuse our units here. This radius is 6. When it goes from the center all the way to the outside, the radius of just the inner part, oh, I guess I could draw like that, it would be 5. So I think what I'm going to do is find the sort of the area of this face. Yeah, it's kind of wide, sorry. The area of that face. I wonder if I could just highlight thinner. Oh, I can. Look at how cool I am. Okay. We'll just like find this ring area times 200, and then that should give to. You could also do full outside sort of cylinder volume and then drill out, subtract a big hole volume, but I'm just going to find the area of this face times the height. Use it like a big prism. And that circle, a radius of 6 and a radius of 5, it's just going to be big circle minus small circle. So 36 minus 25, that's 11. That's the area of this thing. And I have 11 pi times, that's the area of the base, really is what that is, times 200. So I get 2200 pi. And that's it. And then they say use this stupid ratio for pi, or decimal for pi, but if I just do this, it's a lot better, and I get the same thing they had, which is 6911.5. Well, I get a better answer than they had. 6911.5, and that would be cubic. Alright, I'm supposed to convert this volume into a time here. I'm going to go ahead and just mark this as radius, because that's what I care about more. And then we'll have to try to find the height, because I do need to know the volume of this. And this is area of the base times the height. Area of the base here is pi r squared times the height, and I don't know the height, but I have a Pythagorean thing going on here to find height. 6.8 squared is the hypotenuse minus 2.6 squared. Now watch this be a nice number in a decimal of tenths. And I actually get, oh, it is gross. Oh, it's like really close to 2 pi. Oh, that's cool. Divided by pi, like, what? Divided by pi. I'm just curious. What does that do? Yeah, divided by pi. It's like really close to 2 pi. Oh, Can I just say 2 pi? I really want to say 2 pi. Like, they say use 3.14, blah, 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 blah. I'm going to actually say 2 pi. I think that's crazy. That's that close to 2 pi. It's a little bit off to say that, but it's so much easier to write. Let's go ahead and say 2 pi. All right, I'm glad you're playing along. All right, so we have a little bit of pi squared going on here. 2.6 squared times 2 times pi squared. You know what? We're going to have to go to decimals in the end anyway, so let me just go ahead and start down that path now. 2.6 squared times, well, actually it wasn't really 2 pi, it was kind of that answer, times pi. That's really what we have here for this entire volume. It's 42.475. And then the question is, this is approximately now. Actually, this was even approximately, wasn't it? The question is, okay, if this thing is filling up at 1 point, and this is cubic meters, if it takes 1.8 cubic meters per minute, I'll just divide this by 1.8, and I'll get the final answer here. Divided by 1.8, and I get 23.59. Whoops, 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 warning, warning, I did something really wrong back here. That's not the formula for volume of a cone. Cone is 1/3 base times height, you moron. Alright, so this is all wrong. This is probably wrong. Let's go back here. This should have been, gosh, I don't make mistakes. At least I caught it. Whoops, how come I can't? Right. This is 1/3 times all this stuff. Okay, let's talk about this again. And again, it wasn't exactly that. So let me calculate that. Just give me a second. All right, it's more like 44.48. And then I divide that. This is cubic meters. Divide that by 1.8. Why was I so close? What did I do? Anyway, divide that by 1.8. I probably made another mistake. Divide that by 1.8. And it gets really close to 24.7. It says nearest minute. 24.7. What they say 25 in the book. Minutes. Reminds me of a calculus problem where you talk about the rate at which, like the speed of the raising of the level, because it's a cone, it's going to slow down. Anyway, we're just talking about trying to get to the top. That's 25 minutes. All right, about 2.5 minutes. I'm going to try to do this in that much time. This radius would have to be 5 in Pythagorean land. This is 4. This is 3. So actually that tells me the height and the radius. That's kind of cool. And I'm supposed to find lateral area and volume. There's the formulas for those things. Half times P times L. That's 1/2 times the perimeter of the base times the slant height. It's kind of nice how everything's kind of in here. That's 15 pi. Area of the base is then going to be 9 pi times 1/3, which is really altogether 3 pi, times the height. So, whoops, times the height, which is 4. So what I've got here is 12 pi. Very nice. Part B then is saying take this same thing, but let's rotate it around this axis. Well, if you spin it that way, it's going to spin out a cone kind of like this. And this one over here going to the negative side, that's going to be your other edge of the cone. And we're supposed to find the lateral area and the volume of that. So here's the same formulas. Half times perimeter of the base. Now, the base has a radius of 4, so it's 2 pi times 4. And the slant height is 5. And in volume, the area of the base is 16 pi, and the height is now 3. So that's 24 pi. And part C is asking, are these things the same as these things? And the answer to that is no for part C. All right, if we take an equilateral triangle and spin it around an altitude like that, it's going to make a cone that looks like this, where it has the equilateral triangle as a cross section. All right, I got about a minute left. So the radius of this base is going to be 3. So pi 3 squared, that's not bad, but it gets tricky is in what's the height? Well, this is just an equilateral triangle. You're used to seeing this by now, so there you go. So half times 3 squared, that's actually the 3, that's going to cancel. We got 9 pi squared 3. Okay, gosh, I have 45 seconds left. What am I going to do with all this time? All right, that's great. I will go back to continuing on my review videos now. See you over there.